The U.S. public's consciousness with respect to the environment and its relation to life on Earth took a giant upswing in the early to mid-1980s. At the same time, far-sighted people within the laboratory were predicting a downturn in government spending for aerospace and military procurements, two key areas for PSL support. The idea for creating an environmental branch within PSL to take advantage of these trends was the brainchild of Roy Kniff.
We now have a situation where I've seen an estimate that U.S. industry spends about 30% of money which would otherwise go to R&D merely in complying with and protecting themselves against the many regulations that require protecting the environment. So it was in the early 1980s and still is today a growth industry. Growth in the sense there's a great interest in it. There's also a potential for PSL to apply a lot of the techniques, the methodology that we used in missile work, in defense work, in balloon work. We could apply those same set of tools, same people, oriented thinking to help solve these environmental problems.
Once the project has been determined and pretty much laid out in conceptual detail, or actually laid out on the ground, then we go back and determine the key issues in which there may be impacts on what they call the human environment. And all this is determined by statute and federal regulations as to what we do. Once we've determined that, then we conduct the investigations, and these range from biology, cultural resources, water resources, air quality, the impact on the socio-economic region of influence, the impact on regulatory agencies. All these are investigated and turned into a document which provides a pretty clear picture of what the project, how the project affects the region in terms of the human environment. GPS, or the Global Positioning System, gives you you can either do it one of two ways. You can take the readings and come back and reduce them to data and plot them on a map, or you can take them in the field. But what you come up with are precise locations for where an individual is at a particular time where he takes a reading. There are also instruments which will show you fast enough so that you can walk to a particular point with, and now, today, with extremely great accuracy. This is the GIS laboratory. The software package allows points to be located in precise relationship to other points and displayed either on the screen or on the plot, on maps coming off of the plotter.
During its 50 years in existence, PSL has believed strongly in staying abreast of technology changes, particularly in the computer area. From mainframes to mini computers through a variety of personal or desktop computers and workstations, PSL has kept pace with the fantastic increase in computer capabilities, developing software and hardware solutions to existing problems as well as innovative new applications. Today, modeling and simulation is rapidly becoming one of PSL's primary business areas.
Models are numerical representations, general representations of a phenomena of different systems, and simulation. You tie in these models over time, space, and you use controlled inputs for it. And it's used for testing purposes, for development purposes, in streamlining the acquisition process. We originally have had a contract for over 18 years with what used to be the Atmospheric Sciences Laboratory, who is now Army Research Laboratory, Battlefield Environment Directorate. In that contract, we were contracted to do scientific and engineering work, and under the auspices of that, we started doing atmospheric modeling. We've been dealt with one of their biggest libraries, the EOCell library. And from that, we gained our experience in modeling, and we've transitioned it over to simulation. We're going to try to, we're focusing into the distributed interactive simulation arena. Based on the experience that we've had from BED, we're in a strong position to go after more work in DIS.
What we're looking at is an example of distributed interactive simulation, a demo developed at PSL. And what distributed interactive simulation is, otherwise known as DIS, is an environment where people can test equipment, systems, weapon systems, forces, scenarios, all of this in nature over a distributed network based on simulations running in a variety of locations, live firing in various parts of the U.S., perhaps in Yuma, White Sands. And these are all linked together interactively with what they might call ground truth data. And what we see here is our ground truth data is our environment, which is the wind, direction, wind speed, affecting the smoke exhaust plumes on this tank. This simulation is receiving live data from PSL's Met Tower on top of the building. And the data is being relayed to the simulation, which takes the wind direction and the wind speed and affects the velocity and direction of the smoke coming out of the tank. The tank is on a terrain which is, I believe, White Sands. We can accelerate this tank and we can look at the effect that the smoke coming out of the tank has. We can move the tank around and see the direction again of the smoke always being updated again in real time with the meteorological data coming from the top of PSL.
Just like other aerospace R&D organizations, PSL has experienced downsizing during the last few years. However, the laboratory is now stable at about 350 regular employees, 30 students, and contract revenues just short of $30 million. So what does the future hold?
We started looking at a spaceport for a reentry vehicle, and it originally was White Sands Missile Range. They became, well, early in the game, they weren't as interested in this. So we started looking outside the range boundaries and found lots of space. But the whole genesis of launch vehicles for the spaceport came when the DCX folks from McDonnell Douglas showed up. I think it was in '92. We had already been talking about this thing for 2 years, and they had this reusable single stage to orbit vehicle that they were going to test out here, and they were talking about a spaceport. I mean, it was exactly the same idea we had, except they had launch vehicles. And at the time, we had never thought about launching from here, but when you start looking at reusable launch vehicles, vehicles that don't drop things off as they go into orbit, we said New Mexico could do that. We could do that here. So it became a launch possibility as well. The vision we had in the very early days was that we started looking at all the ranges and all the old methods of launching to space, and they all were bureaucracies. They were not commercially oriented. And this was an outgrowth of some of the Comet work when some of the corporations were saying, well, we want to do this, this, and this, and the ranges were saying, oh, well, you can't do that, and you can't do that. And what we wanted to do was to have some place where you can do anything you want to do as long as it's safe.
PSL turned 50 years old officially on the 26th of September, 1996. During those 50 years, the laboratory has grown from a small, largely student-based organization working at Wismar to a large multidiscipline laboratory operating worldwide. PSL has helped probe an expanding universe and investigate a shrinking Earth. And yes, we still launch sounding rockets at White Sands Missile Range.
5, 4, 3, 2, 1, 0. Plus 1, 2, 3, 4.
For PSL, I'm Harold Connell, wishing all laboratory employees, past, present, and future, good luck.